Sydney, Alec, Vinny, and I use calculus to make a graph and use the graph to then create a real-life object that we then will present to the class. Also, we calculated measurements of a goose egg.
So today we're going to be finding the volume of a goose egg using the disk method. This method divides a figure into infinitely many disks, finding the volume of these disks individually in order to find the total volume of the figure. This is obtained by revolving a two-dimensional region about an axis of rotation. So we will first find an equation that accurately reflects the curve of the egg. The height of the egg is 4 inches, and the radius at the widest part of the egg is 1.5 inches. So using these dimensions, we will be able to approximate an equation that can be graphed on an XY plane, and then we're going to revolve the 2D shape around the y-axis, which we will be able to find the three-dimensional egg.
Approximate the size of our egg and the volume of our egg using a graph. We plotted these points 0, 3, 1.51, negative 1.51, and 0, negative 1 in order to approximate the shape of an egg that was 4 inches in height and 3 inches in width. After connecting these dots, we are left with an ellipse shape that is approximately the size of our egg. The equation of this ellipse is x squared over 9/4 plus y minus 1 squared over 4 equals 1. We have to take this equation and set it equal to x in order to find the one side of the ellipse which we will be rotating around the y-axis. This equation is x equals the square root of 9/4 minus 9y minus 1 squared over 16. And that is represented by the red line on the graph, which we will be rotating in order to find the volume of the entire egg. So now we can clearly see that our shape is bound on the right by the red line, bound on the top by 3, bound on the bottom by negative 1, and bound on the left by the green y-axis, x equals 0. We can use this information to find the volume of the egg.
Right now, we're going to work out the actual formula for the disk method by plugging in our equation. So you start out very simply, then plugging in your bounds from over here. Plugging in the actual equation.
Is it gonna fit?
It might.
I think we have to erase the thing.
No.
Erase the thing.
Keep going. Like nothing ever happened. We're gonna keep rolling with this, all right? Chuck that out of there. And then, because this is the disk method, you also have to have your left bound. Even though it is 0 in this, because it is on the y-axis, I will still write it in for clarity's sake. So yeah, there you go. You have the formula set up correctly. And now all you have to do is solve it. And through my magical maths brain skills that I've developed through Miss Seeger's calculus class, I have already determined that the answer is 18.85 inches cubed.